Second example under Kahoot on page 3.
All right, so we're doing this example just as she said there, and this is the second example. So we have a negative 8 nanocoulomb charge here at the origin, and we have a positive 12 nanocoulomb charge here at x equals 1.5 meters, and we're trying to find the equilibrium spot. Now we have opposite charges, so what does that mean? Yes, opposite charges outside on the side of the smaller charge. So we see 8 and 12. 8 is smaller than 12, so that means our equilibrium location is outside and on this side. So what we're going to do next is we have to define the distance to that equilibrium point from the origin as r. So that distance is r that we are placing our test charge q at. That means we also then need to figure out how far is it from the other charge to our equilibrium point. And so in this case, this distance is going to be, well, it's got to do 1.5 and then another r. So this is going to be 1.5 plus r. So let's go ahead, let's set up that equation and solve. So here we go. So I have the two forces having to be equal, F1 equals F2. We then set it up so we have K times Q1 times our capital Q. Again, we're doing those absolute value signs divided by r squared because that's how far Q1 is from our test charge. We then come over here, we have K times our, oops, that's an absolute value sign, absolute value of Q2 times Q times how far away they are. And we divide that by that distance, 1.5 plus r, quantity squared. All right, this is where we're going to start to cross stuff out. After we cross stuff out, we're going to go ahead and put it into our calculator and use solver. So let's go ahead and cross some stuff out. So we got those k's, the same on both sides. We got the capital Q's that cross out. Now we're going to do that cross multiply and solve. So we're going to cross multiply here. So I have Q1 times 1.5 plus r, quantity squared, equals Q2 times r squared. And like I said in the previous example, I like to divide that Q1 over. Again, we do that. We want that Q1 divided by that Q2 so that those nanos will cancel out for us. And again, remember those absolute value signs, especially for one like this where we have a negative one there. So you're not going to put that negative on there. All right. So let's divide that over. So I'm going to divide the Q1 over, and then I'm going to subtract this 1.5 plus r quantity squared over to the other side. And so when I do that, I end up with 0 is equal to Q2 divided by Q1 times r squared minus the quantity of 1.5 plus r squared. And next we just have to plug that into the solver on our calculator. So let's take a look at that next.
All right, let's take a look at plugging this in our calculator now. So what we're going to do is we are going to cross out those times 10 to the negative ninths here. And that's why I like to divide those. Now we just need to plug it into solver on our calculator. So we got to go math, turn it on, go math, get down to solver, type this in. So 12 divided by 8 times x squared minus the quantity of 1.5 plus x quantity squared. Once we get that, we have to plug in an estimated answer. I'm just going to guess a big positive number because there's going to be two solutions to our problem. One of them is going to be negative, one's going to be positive. So let's just put in a big number like say 12, hit alpha solve, and I get 6.67 times, well, just 6.67 meters here for our R value. Now, if you would have plugged in something like 0 maybe, alpha solve, you'll see that you get that negative solution. That negative solution is the answer if these two charges had been the same instead of opposite.